Okay, so you know what similarity means, and you know what it means for triangles to be similar. However, triangles are a little more special than other shapes with more sides, because for a triangle to be similar, really you only need the angles to be equal, right? So if I know those three angles are equal, there's only one way to make triangles if you have the angles, these measurements, right? Does that make sense? Like, if I say, hey, I have a triangle and angle B is, say, 100 degrees, angle A is equal to 50 degrees, and angle C is equal to 30 degrees, right? There's only one way to put those angles together to make triangles, and it is this shape or this shape. So the sizes might be different because the lengths of the sides could change, but the shape, there's only one way to make that triangle. So really, to get triangles to be similar, a shortcut is that you just need angles. And in fact, if you know two angles, you know the thirds have to be equal. So if this is a shortcut, what this means is if two angles of a triangle are congruent to two angles of another, the triangles are similar. Okay, so that's a shortcut. So just like we did with the congruency shortcuts, similarity shortcuts work the same way. There's two other ones. One is a side angle side similarity. Okay, and what a side angle side similarity does is, I'm just going to delete that for a second, is if all we had, so I have my triangles and I say, hey, I know those are whatever they are, X and Y, and then I have another triangle, the angles are equal and the sides are proportional. Okay, and we've talked about proportionality, and this can be kind of confusing. Okay, but if the sides are proportional, so they have the same scale factor, right, multiplied by 2 each time, then the triangles are similar. So if two sides are proportional, right, have the same proportion, and the included angle and the included angles are congruent, so the angles are congruent, the sides are proportional, then the triangles are similar. Okay? And then last but not least, there's the side similarity. Okay, and that means if you don't have any angles but you have the sides, the three sides, if the three sides are proportional, right? If all three sides proportional, then the triangles are similar. Okay, and that kind of works the same way as angle did in our first one, is that if we knew that the three sides were proportional, call that Z to Z, right? There's only one shape that you can put together a triangle. Now, the size might change. You could have a little one or you could have a big one, but the shapes are the same. So these are the three shortcuts that we can use for similarity. Okay, and here's an example of a proof where we might use it in. So here's our picture, here's our given and our proof statement, right? So if we know these are parallel, can we prove that the two triangles are in fact similar? So if I look at this, say, okay, well, I know nothing about the sides, but what do we know about any angles? Well, I know angle C is congruent to angle C, reflexive, right? And angle C is in both triangles, right? BCD is this little one up here, and then ACE is this big one, right? So we want those to be similar. I say, okay, I got to use this parallel line thing. So let's say, hey, I know angle A is congruent to angle CBD because if lines are parallel, then corresponding angles are equal, right? Corresponding angles are congruent. Oh, now I have, let me make this differently. Now I have two two pairs of angles that are congruent, so I can say triangle BCD is similar to triangle ACE, angle, angle, similarity. So that's an example of how you use it in a proof. It's very similar to doing congruent triangle proofs. Okay, you just got to remember that sides are proportional. Okay, besides using the shortcuts in proofs, sometimes you can use them to determine if two triangles are similar. So if I look at these two triangles, are they similar? What I'm going to do is I'm going to match up the smallest sides and say, okay, 8/4. And then I can match up the middle sides. Right, does that equal 10/5? And then we'll match up the biggest sides. Does that equal 11/5.5? And in this case, yes, these are all true, right? Yay. So these two triangles are similar by side, side, side similarity. And if we're going to write a shortcut, ABC, just like in congruent shortcuts, the order is really important. So ABC goes like this, right? ABC. Let's make a smiley face here, sorry. Okay, so now you got to really think about A is between the smallest and the medium. So this is there. And then we go right towards the biggest. See how I'm thinking about this? And then the final one. So ABC is similar to triangle MLT.